And then we'll be using these to model distributive property in action. We're going to be making ourselves a little memory game. And you know how like when you play memory, you have a whole bunch of cards mixed up, they're face down, and you match a pair when they look the same, right? So when we match a pair today, they're not going to look the same, but their value is going to be the same. Does that make sense? So we're going to work on building equivalent expressions using factoring. And this is setting the stage for solving multi-step equations down the road in algebra. But we've been through finding exponential expressions that relate to factoring. We've been through this, greatest common factor. So you're going to use all of that today when talking about distributive property. Everyone hear me okay? I'm in the cafeteria and I don't have my earbuds with me today. And it is lunchtime, so it is a little bit noisy coming back and forth from recess. So please let me know if there's a time when you can't hear me, okay? So distributive property, if you would like to put this down in your notebook, this is a good tried and true description of distributive property. Distributive property means that multiplying a sum by a number is the same as multiplying each of those addends by that same number and then adding those products. So you might be thinking, like, this is a very wordy expression, but break it down. Multiplying a sum, so what's a sum? It's two terms being added together, right? As demonstrated right over here, multiplying a sum by a number. You will get the same answer if you did it this way. If you multiplied each of those addends by the same number and then added together the products. So do you see how Julia's way and Risa's way ended up resulting in that same overall value? So we're learning how distributive property allows us to transform the way an expression looks so that we can get after maybe a piece of it that we don't know yet, and that's algebra. In order to do this, we're going to rely on our sense of greatest common factor. So pulling out maybe your multiplication charts, that will help you discover that greatest common factor. We have a couple here on the page. I'm going to just annotate that I'd like you to copy into your notebook, okay? So this is for section 6.3. And this is the guided practice that is going to help you understand how these two expressions are equivalent in value. And then we're going to practice some using our distributive property memory cards that we're going to make, okay? So I'm going to start with the passing out method. And the passing out method of distributive property is a little bit easier to swallow because I think we have at least done this before when we worked on equivalent expressions. My pen's not writing just right. Wow, why is it writing so slow? That's interesting. Why is it writing so slow? Can you guys see how slow it's writing on the screen? I wrote that like 10 minutes ago. Why is it writing so slow? Here, let's hope it's gonna work now. Oh no. Well, do I have to also talk in slow motion? So what is slowly becoming clear on the screen? Distributive property is, it's going so slow, is passing out the factor of 5 to each of those addends inside, creating a final product of both 25 and 45. It's slowly coming to life there. Do you see that? You have to wait for it. It's just patience here. 5 is being passed out to this factor of 5. 5 is being passed out to this factor of 9, creating a new expression called 25 plus 45, right? How about this next one? So what's being passed out to both of these addends? The 7, the factor of 7. So 7 times 3 gets you your 21, and then 7 times 8 gets you your 56. And each are getting that factor distributed to them evenly, equally. All set with that? So passing out method isn't as hard to understand, but what I really want you to understand is here, I'm gonna stop the share. Maybe it's going in slow motion here, and that's really hard to teach when it's moving like at 1/10 of the speed that you're talking. So I'm gonna stop the share and then try it again, and we'll see if the annotate will work a little better this time. Okay, let's see. All right, perfect. It's back up and running. I don't know what that was about. That was kind of creepy. How, oh, no, my pen's not working. I'm just gonna have to use the mouse. Sorry about that. Nothing can ever just work properly, can it? So distributing method is easy when it's the passing out version, but when it's the collecting version, you are looking inside of this number and inside of this number for common factors. And you might need to make a factor tree in order to understand which factor it is. But break down 15 for me. What prime numbers are inside of it? A 3 and a 5, right? And what prime numbers are inside of 35? A 5 and a 7, right? So what do they have in common with each other? What do they share? They share a 5, right? So if I were to collect a 5, just like I did with these expressions down below, oops, wrong one. If I were to collect a 5 from each of these terms, what would be left over in terms of the 15? The 3 would be left over. What would be left over in terms of the 35? A 7 would be left over. So how do we put that together as an expression? So we put the term that we've collected out front, and then we put what's remaining of that add-in inside, and what's remaining of that second add-in on in this position. And if we went backwards to just check it, and we pass that 5 back out, do we end up getting what we had to start with? We do. We end up getting what we had to start with. So same technique. What factor am I pulling out of 12 and 27? I'm pulling out a 3. And what would be remaining if I took a 3 out of 12? The 4 would be remaining. What would be remaining if I took a 27 or a 3 out of 27? A 9 would be remaining. And you could check that in reverse by passing out the factor of 3 back and just saying to yourself, okay, 3 times 4, that makes 12, 3 times 9, that makes 27. So it works. Now, I understand that the value of each of these expressions, they're both worth 50. I know that. It's not about finding an answer today. It's about manipulating expressions to transform into different formats. And we'll need that skill to move forward in algebra for situations like this, where let's say you have a problem that looks like this. It says 5 times x plus 2 is going to be equal to, let's say, 20. And I would say, solve for x. Well, yes, you know how to identify the variable. You know how to do that. But your balanced move is a little more complicated in this sense because that x variable is trapped inside of the parentheses, right? So you need a technique for getting that x value out of the parentheses. And you know what to do now because you understand how distributive property works, right? So you could say, well, I can get the x out of parentheses by distributing the 5. And that would be another name for 5 times the quantity x plus 2 would be this. 5 times 2 is 10, right? Did I release the x from his barricades? Did I get the x out? So now that the x is out, I can start moving some things around to get it alone. And to get it alone, I would make a balanced move. This is step 1 of my balanced moves, right? And then I would eliminate those 10s since they cancel each other out. Are you starting to see what your next balance move would be? What's your next balance move? would be to divide by 5, right? On both sides. And finally, what would that last part of the simplifying result in? 10 divided by 5 would be 2. So you see how we were able to use distributive property to unlock that variable, and then we could manipulate using balance moves and things like that to solve. So that's what's coming. That's the purpose of today's activity, is not to find equality, but to be able to transform the way an expression looks into different formats so that we can be better problem solvers for algebra, okay? So let me show you on the next slide a little bit more complicated ones. If I were trying to demonstrate distributive property between these two numbers, finding a common factor between them might be a little harder because they're bigger. I know that they have 10 in common with each other, and I used a factor tree to find that. So if they have 10 in common with each other, if I removed a factor of 10 from 500, what would the remaining factor be? It would be 50, right? And I know they're both composite numbers and could continue to break them down, bust them up into Lego primes. But if I do that, I'm still going to result with 10 was able to come out of 30 as well. So I know 10 is the one. 10 is the greatest common factor that I can harvest from both of those terms. So I put my shared factor out front. The leftovers on the inside of the parentheses, I can check it by moving backwards and passing that 10 back out. And did it work out? They're equal in value, right? Same will work when there's subtraction between the terms. It will work exactly the same. So the only difference is instead of having an addition symbol between those addends, you would have a subtraction symbol between them. And you can see this other example follows that same process, that same technique. How are we feeling so far about this? I need some feedback. Okay. Paige, how are you feeling about this? I haven't given instruction on what to do on that paper yet. So how are you feeling so far about passing it out and collecting? Ryan, how are you feeling? Okay. All right. Now on to our guided practice, more of your independent practice, the distributive property memory cards that we're going to be making. Now I'm giving you one half of the flashcards, and you're going to build me equivalent expressions for the other half of them. So if I gave you the format that looks like this, 15 plus 35, you're going to give me the equivalent expression that looks more like this with the product of the addends, okay? Using that pull out factor approach. And we'll do a couple here together. And then when you're done, would you just don't cut them out until you have this whole page done, and send me a picture of this whole page. Then you can cut them out and get them ready for our game. So what I did with the other classes was I put this up on the board, and then I'm going to help you translate a couple of them to get started. But I'm going to write on top of the first card, you're going to write it on the fresh card, on the clean card. Why? Because you want the pairs to match when you flip them. We don't want both answers to be on the same card. We want one version, one expression, and the matching expression to be on a different card. So when we pick them up, we know they're a match. Does that make sense? So I'm going to write the answer on here, but you're writing it on a fresh card. So what would the shared factor between 5 and 35 be? Didn't we just do this one? What's the shared factor between 5 and 35? It's 5, right? That's the shared factor. So what's left over when I remove the 5 from 15? You guys are going to have to unmute and talk to me. This is no different than in a classroom. I need feedback to be a better teacher. So what
3.
factor would be left behind?
3 and 7.
7. Thank you. 3 and 7. So this is how I would write it, but don't write it on this card. Write it on a fresh card so that you have something to match it with when we play the game, okay? All right, good. What do 21 and 56 share? If you don't know, make a factor tree and figure out what they share. They share 7, so I'm going to pull my 7 out and collect it from each term. So if I took that 7 factor out of 21, what would be left behind?
7 and 8.
Well, if I took the 7 out of 21, here, I'll do a little quick factor tree here. If I took 7 away from 21, what factor would be remaining?
3.
The 3 would be remaining, right? So if I took a 7 away from the 56, what factor would be remaining?
8.
The 8, right? Or if you broke it down into primes, you would see 2 times 2 times 2 is left over, which you know 2 times 2 times 2 makes 8. So we are working on collecting a factor when they're written like this. And what are we working on when they're written like this? Passing out a factor. So what would 6 times 1 be? 6. And what would 6 times 4 be? 24. So I understand that the value of both of these expressions is 30. I get that, but I don't want that written on your cards. I want distributive property equivalent expressions, one on each card so that they can be matched. Do you have any more questions about what I'm expecting for these memory cards or how to organize it?
No.
Okay, stay on until they're all done and you can show them to me because I want to check them before you go so that you're using the right cards to play the game. Does that make sense? So I'm going to mute. You go work for about 5 minutes. That's as much as it should take. And then you're going to show them to me in about 5 minutes, okay? Either distribute, pass it out, or distribute, collect. Go ahead.
I'm using these note cards. Is it okay if I use these?
Yes. And then Penelope, you'll have to write these expressions that are already on my cards. You'll have to write those down. If you're not going to print this, you're going to have to write those down as well to be the other half of the winner. Yes, Paige, do you have a question?
I don't know like how to make like the factor for 66.
Okay, did you make a factor tree yet? Did you make a factor tree yet?
Oh, that's what I'm confused on.
Okay, so if you're wondering how to split 66, check your multiplication chart for wherever you see 66 happen. And then the two factors that create 66 will be the ones that branch off of it. And if you can't find 66 anywhere, then you start thinking about your divisibility rules. And if 66 can be divided by 2, it will end with 0, 2, 4, 6, 8, which is true. It's an even number, right? So you could cut it by 2, but what else might help you get that answer faster? Did you figure out a number yet? What do they both share?
33 and 2. Oh, for the factor tree of 66, I got 33 and 2.
Okay. And then keep going. What's 33 split into?
11 and 3.
Keep going with the 18 now. What's 18 split into? You're getting there. It's close. It's close.
6 and 3.
Okay. Keep splitting them all the way down. I'm going to do it here on the screen.
After I get 11 and 3, do I have to like not split it anymore?
Right. Because why?
Because both of them are prime.
Good job. Yes, because they're both prime. So stop, you know, when we circle our prime numbers, it's like a stop sign. So that's why we're doing it, so that we can break them all down into primes and then compare how they relate to each other. So if I were comparing these two numbers, what do you see now that they have in common? So this was a
2
good
and 3.
2 and 3. What does 2 and 3 make together?
6 and 6.
6, right? So 6 is what they share. So if I took a 6 out of 18, what can you see is left over? What factor?
3.
3 is left over. And if I took 6 from 66, what's left over?
11.
You got it. So how do we write that? This is how we would write it, is the 6 is out front because that's their greatest common factor. And for 18, the 3 is remaining. And for 66, the 11 is remaining. Now do me a favor and pass that 6 back out. Did you get 18 and 66 when you passed it back out? Then you did it right. Charlotte, honey, I know you got on a little bit late. How are you feeling about this?
I think I'm getting it.
Okay. What did let's do this one together. What did 12 and 27 share? What did they share? What factor?
Um,
And if you don't know, we got to do factor trees to figure it out. So how could you split a 12?
you can split it 6 times 2,
Sure.
and then you can split 6 3 times 2.
Mm-hmm. And so that one's all primes, right? So how do I split
Right.
27 now? 9 times 3?
Yeah.
Okay. And 9 keeps splitting, right?
Right. Into 3 times 3.
Now they're just 3 and 3 and 3. What do they share? What do they have in common?
3.
How many 3s? Or just 1 3?
Just 1 3.
Just 1 3. So that's going to be the factor that I'm collecting from each of those terms. So if I collect a factor of 3 from 12, what's left over? These 2 times 2. What's 2 times 2?
4.
4. So 4 is left over for the 12. And what's left over for 27 if I take out one of the 3s? 3 times 3.
9.
Which is 9. Now pass that 3 back out and make sure that it matches. Is 3 times 4 this number? Mm-hmm. And is 3 times 9 this number?
Yes.
Mm-hmm. So you're doing it right. Anyone else need some support here? Natalia, you joined a little late. Are you feeling okay? Nicholas, William, Jesus, what's going on? Talk to me. How's it going?
Good.
Good. I'm just gonna start typing the answers here on the screen so that you can compare them to what you have. But please let me know if anything I'm writing doesn't make sense. That way I can give you some support with it, okay? So for this first one, we put the equivalent expression would be 5 times 3 plus 7, right? And for this one, the equivalent expression was 7 times 3 plus 8, right? Let me pull this over a little bit more. And for this one over here, Paige and I pulled out a 6 and found that the leftovers would be 3 and 11. And for this one, Charlotte and I pulled out a 3, and we were left with 4 and 9. Those are the hard ones. That first row is a little tough. The collecting is tough. And for this one, what factor comes out of both of them? When you factor them out, you end up getting that they have 2 2s in common with each other. So what would 2 2s be? It would be 4, right? So if I take a 4 out of 28, that's a 7. And if I take 4 out of 52, it ends up being 13. The very most I can take out of this one is a 2. And I'm left with 7 and 20. These are a piece of cake. Pass that 6 out. 6 plus 24. What's this one? 12 plus 24. Any questions about those first 2 rows that I just did? Feeling good about that? Okay. And then here's the last row for you. This first expression, pass out the 5, would be 25 plus 45. The second expression, 48 plus 8. The third one, 2 plus 8. And then the last one, 15 plus 3. So what we're going to do tomorrow is here. Just show me your cards. Just show me your cards. They're filled out. Yeah, cool. That's what I want a picture of on the Google Classroom, okay? It's just your card set. You obviously don't have to show me the ones I did for you. But then after you take a picture of it, you're going to cut out both sheets. And tomorrow, what we're going to do is put them all face down, mix them up, mix them up. And then when you pick up 2 cards, you should have equivalent expressions. And if you don't, put them back down. And then you pick up 2 more until you can play this memory game. And you're matching them according to value. So it's like you're constantly calculating and working on equivalencies at the same time. So I think this will be a fun way to practice distributive property. And then the next day, we're going to get into more of our workbook pages involved with it and a little bit more algebra laced into it. So I hope that you're feeling good about this. And I can stay on for about 5 more minutes if anyone else has questions right now, but feel free to contact me later on if you need more help with the distributive property cards, okay? I'm not sure if you happen to see that the corrections video went live. I'm about halfway through your class grading your chapter 5 quizzes on the inequalities, this quiz. This one. I'm about halfway done, and all of my online people, I have manipulated your quiz on the screen. So in order to see which ones you got right or wrong, you're going to have to go back to your original posting, and it will show you all my notes that I've put on your page. It's sort of like I was writing on your test, but I was writing on the screen. So it should have saved all of my annotations for you to look at what I had to say about each question. I did make a video also to assist you with correcting your test. So please use that. If you got any wrong, any part of any particular question wrong, please redo it. It's going to help you be a better student moving forward. If you take another look at what mistake you made so that you don't make it again moving forward. I'm here for any questions about that quiz that you just took also. So please watch the video first. I put in some good remedial instruction into that video to help. But if one particular section really knocked you down, then you need to go back and revisit that particular topic in the Google Classroom. So if, for instance, section 5.7 was really tricky for you, then where do you need to go back and revisit 5.7, right? And there's videos and resources at each of those places for you to use, okay? I am almost done grading your test, so hopefully in the next hour, yours will be marked, returned, ready to go, but those aren't due until Friday, so you have a couple days to work through them. 6th grade doesn't have math again on Thursday because we have half day here, we're going to Mass. You have your other subjects that day, so you do have a light week. So make use of it, do those corrections on time, they're worth assessment points. All right, I'll see you guys, take care.